Good afternoon, everyone. My name is Neha. I am from IT department. My topic is security issues with functions as a service. Introductions to functions as a service. Function as a service is a serverless computing model where developers deploy code in the form of small functions that run on a demand triggered by events, example like HTTP request, file uploads, database changes. Popular functions as a service platforms are AWS Lambda, Google Cloud Functions, Azure Functions. Key advantages: no server or infrastructure management, pay per use, cost effective, automatic scaling based on demand, fast deployment, and event driven execution. Why security is critical in fast as a service? Fast function as a service introduces the unique security risks due to its dynamic and abstracted nature. Traditional security models often don't apply directly, making cloud native strategies essential. Multi tenant environment. Cloud providers host multiple customers on shared infrastructure, increases the risks of cross function data leakage or side channel attacks. Impairment and event driven natures are functions spin up and terminate quickly. Attackers can exploit a short-lived attack windows via event manipulation, limited developer control, no access to the underlying operating system or runtime environment makes monitoring and securing infrastructures harder. Dynamic attack surface. Functions are triggered by a wide range of external events. The entry point constantly changes, increasing the vulnerability exposure. The management plan is nothing but the applications, etc. And the middleware runtime and servers operating systems. The compute management plan includes the VM and the hypervisor, and the management plan of the storage includes the object volume and storage array, and the network management plan includes the switches, routers, firewalls, and the VPNs. Key security challenges in functions as a service. Functions as a service introduces specific security challenges due to its stateless, event driven, and the external dependency heavy nature. Short lived functions lifecycle. Functions spin up briefly and then vanish, difficult to track, log, and investigate after an attack, reduces the effectiveness of the traditional security tools. Event injections attacks. Attackers manipulate the event data, example HTTP and S3 triggers, malicious inputs, and can trigger an unintended code execution. Broken authentication includes the insecure functions. Endpoints may lack proper authentication, risks of an unauthorized access of the internal services. Insecure third-party dependencies. Serverless uh, serverless apps rely heavily on libraries packages. Outdated or unverified dependencies can introduce known vulnerabilities. Multi-tenancy risks. Fast functions as a service platforms are multi-tenant by design, meaning functions from different users or organizations may run on the same underlying infrastructure. Key risks: cross tenant access. One tenant's functions might accidentally or maliciously access another data or a resource leakage. Improper functions isolations can lead to exposure of memory, logs, or cached data. Side channels attacks. Attackers exploit CPU or memory behavior to infer sensitive data from co-located functions. Why it matters? The shared nature of the function as a service make isolation and the sandboxing critical for maintaining security boundaries. Event injection attacks. In functions as a service, functions are often triggered by external events such as API calls, file uploads, or database changes. If not properly validated, these events can be manipulated to launch attacks. How it works? Attackers send malformed or malicious event data. The function trusted the event blindly, executes the unintended behavior. Examples: API gateways injections, injecting malicious payloads via HTTP headers or JSON bodies. S3 event exploit, uploading crafted files to trigger insecure processing functions. Risk: without the strict input validation, event driven logic becomes an attack vector. Dependency vulnerabilities. Functions as a service application often depend on external libraries and packages to speed up the development. However, these dependencies can introduce hidden security risks. Key issues: heavy reliance on third party code. Many functions use open source packages without deep review. Unpatched vulnerabilities. Outdated or vulnerable dependencies can lead to remote code execution and the sensitive data exposure. Limited package scanning. Some functions as a service platforms lack automatic vulnerability scanning, leaving risks unnoticed. Impact: a single vulnerable dependency can compromise the entire function or a cloud environment. Logging and monitoring limitations. In functions as a service, functions and ephemeral, they run for a few seconds and then disappear, making attack detection and forensic analysis difficult. Key limitations: short lifespan of the function. Logs may persist after function execution. Hard to trace the security incidents or failed execution. Limited runtime visibility. Minimal insights into system level behavior. Example like memory usage, network access. Cloud provider gaps. Developers have restricted access to underlying infrastructure logs, unlike in traditional server. Impact: these limitations can delay incident detection, response, and recovery. Best practices for securing the functions as a service to reduce the security risks. In functions as a service, developers must adopt the cloud native security strategies tailored to the serverless environment. Key best practices: principle of least privilege principle of least privilege. Grant functions only the permissions they strictly need. Input and event validation. Sanitize and validate all external inputs and triggers. Secure continuous integration, continuous deployment pipelines ensures code is tested, signed, and reviewed before deployment. Monitoring and logging uses tools like AWS CloudTrail, Azure Monitoring, and GCP Cloud Audit Logs. Regular dependency scanning use tools like Sync, Dependabot, or NPM Audit to identify and patch vulnerability packages. Logging and monitoring limitations. In functions as a service, functions they run for a few seconds and then disappear, making attack detection and forensic analysis difficult. Key limitations: short lifespan of the function. Logs may not persist after function execution. Hard to trace the security incidents or failed executions. Limited runtime visibility. Minimal insights into system level behavior. Example: memory usage and the network access. Cloud provider gaps. Developers have restricted access to underlying infrastructure logs, unlike in traditional servers. The impact of the logging and the monitoring limitation is nothing but these limitations can delay incident detection, response, and the recovery. Principle of the least privilege. Conclusion: function as a service delivers speed and scalability and the cost efficiency, but it also introduces the new attack surfaces and operational blind spots. Final takeaways: function as a service increases the agility ability but introduces new security concerns. Developers must adopt a proactive, layered, and the security strategies. Security in serverless is a shared responsibility between cloud providers and the users. The future will bring better native protections, enhanced monitoring, and zero trusted functions isolation. Thank you.